Hey, third grade math lab, how are you today? This is our only video for the week of April 27th through May 1st. And I wanted to have you go ahead and get your supplies ready. You're going to need your Star Master Quick Review book, and you're going to need your fraction packet that I made for Math Lab. And you're going to need a pencil too. And we're going to be working on page 66. So if you don't have those supplies, go run and get those now, pause the video, and then come right back. All right? And we're going to be looking at number 1 here. We've moved to a different type of math now, and the type of math that we're working with is geometry. So our questions, a lot of them are going to be about geometry, okay? And that's the study of shapes and things like area and perimeter and all of those neat words like, angles and line segments. But let's go ahead and let's just get started, dig right in. So we're on number 1. We still use our cube strategy. So let me pull that up real quick. We're still going to be circling and underlining. But in some of these, sometimes we won't see a math action word or things like that, but we'll get used to that. But we're still going to be using our cubes. So make sure you remember that we don't solve any math problem until we've thought through it carefully. So here we go. It says, what geometric figure is shown below? Okay, so if there's anything I can circle or underline or notice in here, it might be geometric figure. Okay, that gets my brain ready to know something. And I know it's sitting right here. A lot of times, if you're looking, and this is a 3-dimensional figure, okay, that means that it has a way to measure its height, okay, its width, okay, its depth. So it has 3 ways to measure it. So that's why they put these little dotted lines and the shading in to make it appear as though it's coming off of the page, to make it look like it's not a flat geometric shape. Okay? So if we look at it, and we have our 4 choices over here, a lot of times it's a good idea to have a picture of something in real life in your head. What does that look like in real life? If I were to take that and I were to turn it around or turn it upside down, what would it look like? Would we call that a circle, a cone, a cylinder, or an oval? Okay, well, I think most of us know, okay, what this shape is, but if we were to flip it, okay, wouldn't it look a whole lot like an ice cream cone or a cone that you could put ice cream in? Okay. So always try to think of something in our real life or out in the world that this shape could be. And a lot of times that might help you remember it a little better, okay? These other shapes over here, I'm not going to go into them today, but maybe next year we can go into those type things. Let's look at our next one. Now we studied these as 3rd graders. We studied a lot of shapes, okay, right before we left for spring break. So let's talk about what this question is asking us. It says, which figure best represents a rhombus? Okay, so I know that I'm going to be looking again at geometric figures, okay, and I want the one that is going to be the rhombus. Okay, well, first of all, if you can think back into what we talked about rhombuses, we said rhombuses were quadrilaterals. Okay, so what is a quadrilateral? It's a 4-sided figure. So a rhombus is going to be a 4-sided figure. Can we automatically mark one of our choices off? Well, sure we can. Okay, and then we're just left with 3 choices now. So we look at rhombus and we say, okay, what was the special thing to remember about a rhombus? Well, it was a quadrilateral. Of course, it's a polygon. Okay, and so we have all of those things here left. And then we had to remember that the very special thing about a rhombus is that all of the sides were equal. Now, not like a square, because a square had to have equal sides, but all 90-degree angles. A rhombus didn't have that one rule. So we look through here and we think, not all of the sides are the same sides. We have a left and the right that are the same and a top and the bottom that are the same, but not all of the sides are equal. We look at this shape right here. Definitely not all equal sides on this one. But if we look at this shape here, it looks kind of like it was a square that was sat on. And that's how I remember a rhombus. A rhombus is like a square that got sat on. And yes, a rhombus is a polygon that is a quadrilateral with 4 sides, and all of the sides are equal. Okay? All right. So let's go to our next page. Our next page we'll be working from is page 67, and this is the page where I'm going to ask you to pause the video at certain times, do the work, and then come back to see if you've gotten it correct. So we'll read number 3 together. Mrs. Drake wants to plant an herb garden like the one shown in the drawing below. This was just information. I don't think that there's anything that we need to underline here. They didn't say the name of this shape. They just said it was just an herb garden, okay? And if I take a look at my shape, I see that it is a 4-sided figure. One side is 3 yards long, and the other side is 5 yards long. It says, what is the area of the garden? I see it. I hope you did too. The area is our key word. You have to know what area is, though. In math or in geometry, we have a formula for area. And the formula for area is, I'm going to abbreviate area with a capital A, and I'm going to say area equals length, that's an L, times the width. So I have to know what the length is. The way I remember the length, I always say length starts with L, and so I'm always going to say the length is the long side. Length, long, and the width, I like to think of as the shorter side. So if I were to take and I were to use the length and width of my shape here, could I find the area? Okay, I'd like for you to pause the video, come back, and let's talk about your answer. So pause the video now. All right, let's come back and let's look at some of the work that I've done on the page. Okay, well, one of the things that I did was that I took my area formula and I replaced the letters with numbers. So the length was 5, I circled that over here. The width was 3, circled that over here, and then I placed my numbers in here, and then I just did the math. There are lots of ways that you could think about area, okay? But one way that they'll sometimes show a 3rd grader is that they'll actually show the squares inside of the picture. If they do that, you can check your math by counting the squares, because area is square units. And square units are made by multiplying 2 numbers together. All right? So if we look, if we did our math right and we did our counting right, then our answer would be right here, 15 square yards. Sometimes they don't make the picture so easy. Sometimes they will not put those numbers and those boxes or anything on the inside there. And so you just have to know that the area, when you're given the length and width, you multiply for those. All right. And let's go down to our other picture right here. Okay. And it says, the 2 figures below are congruent. Well, you have to know what the word congruent means. So I'm going to go ahead and tell you congruent means completely equal. They are exactly equal to each other. So that means if I were to set figure A exactly on top of figure B, they would cover each other. They would be exactly the same size. Even though there's other stuff going on the inside, the outsides would be the exact same size. It says the shaded portions of the two figures represent. Okay, so we know that we need to do some underlining here. Okay, so we only need to be looking at the shaded portions. I'm going to get a little skinnier pen for this. So I need the shaded portions is what I'm paying attention to. And so I need to look at the shaded on both of these figures. Now, when you're given a problem with a lot of reading, it's a good idea that you check out the answers to see maybe what they're asking us. So in the shaded portions, is it going to be A, different shares of different wholes, and whole meaning the whole thing, identical shares of identical wholes, different shares of identical wholes, or identical shares of different wholes? Well, number one, when you're given this many words and a lot of things to think about, you need to kind of narrow your choices down to maybe even the best two if you can get rid of two choices. First of all, they told us that these figures are congruent. That means this whole figure is congruent to this whole figure. That means they're the same or they're identical. So if I look at here, A says that if I'm comparing these shaded things, it would be on different wholes. They're not different. I know that can't be my answer because it told me right away that these were congruent. But this answer mentions something about the whole things being different. I need something in the answer that says identical wholes. Well, the bottom one says different wholes. You can't have different wholes in this problem for your answer because the wholes, these whole things up here, are congruent. Or another way to say that is identical. So I don't want to choose anything that says that the whole things are different. So we're going to look at our next two answers. So it says identical shares of identical wholes. That means these two things right here, okay, this one and this one, okay, are the exact same size as this one and this one if we were to put them together. And this one, B, says different shares of identical wholes. Well, that means that if you put this together with this, it would be different than if we had put these two together. All right, so I want you to make a choice, and I'm going to show you what the answer looks like. So pause the video, make your choice, and then turn it right back on. Okay, did you make your choice? All right. Now, unless you've studied this, it's kind of hard to see whether these are like this square is the exact same size as this triangle, and this square is the exact same size as this triangle, or if they're different sizes. So I wanted to show you a picture of that. So what I did was that I put a shape on top of this, and if you'll notice, it's the exact same size as that shaded area. I'm going to set that over there. And then I have two triangles that I set on top of this. And so I think you would agree that these two triangles take up that space exactly. So if I were to set these out here, okay, and set them on top of this square, I think that one needs to be tipped a little bit more. I think you would agree they make the same size. So looks can be a little deceiving, can't they? So the shaded area of figure A is the exact same shaded area as figure B. So our answer for this one is going to be they are identical shares of identical wholes. All right, so that was a little neat, wasn't it? Okay, so geometry can be fun as well. Now, we're done with this page. So that was page 67. Hope you learned a little bit from that. And now we're going to go to, oh, there's my son. We're going to go to our fractions page real quick. So let me grab my fractions page here. All right, there we go. And we are going to be on page FD1. And this page has number lines all over it. So let's let you turn to page FD1. Make sure you have that. Make sure you have your pencil. If you don't, pause and then come right back. But we're going to talk about the use of a number line when you're making fractions. Okay? The first thing that you need to know about number lines and fractions is fractions work the exact same way as they always did. They have to have a fraction bar. They have to have a number on top called the numerator. And those are the things that you look at. Okay, so your eyes are on your head. You nod your numerator, things you look at. And then the bottom is a number that's the denominator, and that's the whole amount. And remember how we remember denominator? Denominator can be D down or D dance. So you dance the down part on denominator. All right, those are just silly ways to remember it. But I'd like for you to look at how you find a fraction on a number line. So we're going to look at this first one right here on page FD1. And the way I teach students to do that is, first of all, notice the numbers on your number line. And I notice that each of my number lines go from 0 to 1, 0 to 1, all the way through here. And that's the easiest way to start off learning fractions. And they all have different spaces between. And that's okay too, and we'll figure out how to do that. Number one, don't count the lines. The lines can confuse you. So if I were to count the lines and I were to say 1, 2, 3, oh, this has 3 lines in it. It must be thirds. No, we don't count lines. We always count spaces. So if I were to come in here, if you can see my little circle here, I would count only the spaces. And I would say 1, 2, 3, 4 spaces between 0 and 1. That means that my fraction has 4 equal pieces because these pieces in here look equal. Then I need to count how many spaces over. Okay, so I'm talking about fourths. I'm going to make myself a skinnier pen here. And I have gone over 1 space here. So if I have gone over 1 space and I'm counting by fourths, this is 1/4, isn't it? So 1/4. All right, getting the hang of this now? Okay, so let's come over here and let's count our spaces only, not lines. 1, 2, 3. We're talking about thirds. If I wanted to label every line on here, let me get a little tiny skinny pen. I could say, okay, if I hop 1 over, this is 1/3. Another hop would be 2/3, and a final hop would be 3/3. And if your numerator is the same as your denominator, it's 1 whole thing. So my dot, or on my line, I stopped on 1/3. Let's go down to the next one because it goes past that first line. I encourage students to always label all of theirs. So if I were going to go by my rules, I'd say label all of your marks just so you know that you've gotten it completely correct. All right, so I'd go all the way over here. So let's look at this one. It goes from 0 to 1. My dot stops before the 1, so I know it's a fraction. Fractions come between the numbers. Okay, and so let's count the spaces on this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has been cut into ninths. So if I were to label each one, I would start and I would say 1/9, 2/9, 3/9. And I know it might take a couple of minutes, I mean, you know, a little extra second or two here or there, but it's always worth labeling just to make sure that you're right. Now I'm on 5/9 and then 6/9. Notice how my bottom denominator number is the same. That's because it's the total pieces. Okay, 7/9, and then I have 8/9, and then if I do my final, I have 9/9, and that better end up on the 1 whole mark, and it did. So I would go, okay, my number line has been marked on 8/9, and I put that TH at the end when I say that. Okay, I know I've given you a lot of these FD pages. I think you have an FD 1, 2, 3, and 4. That's just if you wanted a lot of extra practice, but I encourage you, do the practice on your fractions. Take time to practice fractions on a number line. If you have any questions, remember you can always give me a call or a text or email me, either one. Make sure you're spending time on Study Island. I am so proud of you. There are some of you who need to pick up the pace. 30 minutes a week on Study Island is important to keep your math skills up. Thank you for coming to visit me today. I miss you guys, and I will talk to you on the next video. Bye-bye.